Students, my name is Sir Alexis John Inge. I'm your teacher for today's lesson. Our lesson for today is about the factor theorem and the polynomial equations. So first, before we tackle about the factor theorem and what is the polynomial equation, we must first know the definition of these terms. So we will discuss first what is factor theorem because we will be determining the roots of an equation later using the factor theorem. If x minus r is a factor of p of x, then p of r is equal to 0. This means that if the answer is 0 or if the remainder is 0, therefore x minus r is a factor of that certain polynomial. It's easy, diba? Dali na kaayo. Okay? For my math students out there, I will be speaking or using English as a medium of instruction, but time to time, I will be using Bisaya for you to understand. Okay, let us use this example. Show that x minus 2 is a factor of p of x is equal to x cubed plus 2x squared minus 5x minus 6. There are two ways of evaluating if x minus 2 is a factor of this polynomial. It's either evaluating or using synthetic division. Now, by evaluating the p of x, if r is equal to 2, we will now substitute the value of 2 to the polynomial. So as you can see, 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6 is equal to 8 plus 2 times 4 minus 5 times 2 minus 6, and it will become 8 plus 8 minus 10 minus 6, and the answer is 0. So the p of 2, when substituted to this polynomial, is equal to 0. So this means that x minus 2 is a factor of x cubed plus 2x squared minus 5x minus 6, since the answer is 0, or the polynomial has no remainder when it is going to be divided by x minus 2. And by using synthetic division, as you can see, the remainder is still 0. Another example. Show that x minus 2 is a factor of p of x is equal to x cubed plus 2x squared minus x minus 2. By using the synthetic division in showing that x minus 2 is a factor of the polynomial, we can see that the remainder is 12. That only means that the polynomial x minus 2 is not a factor of this polynomial. Gets? Okay, so for you to understand and to be able to grasp the idea, I will give you some activities to make. So answer this in less than 2 minutes. And you may pause the video in answering the questions. You may repeat the video for you to understand the lesson. Okay? So para sa akong mga estudyante diha, pwede ninyo i-review or i-rewind ang video para mas madali ninyo o tuon ang atong lesson karon. We will now discuss the next lesson, which is polynomial equations. A polynomial equation is obtained when a polynomial expression is equated to 0. The standard form of the polynomial equation of degree n in one variable is written in the form where a sub n minus 1, a sub n minus 2, to a sub 0 are real numbers. Before we tackle about the polynomial equations, let us first know what are the different parts of a polynomial equation. The degree of a polynomial equation is determined by the highest exponent of the variable. The root of a polynomial equation is a value of the variable which satisfies the polynomial equation. The leading coefficient is the coefficient of the term with the highest degree in a given polynomial. So we are already done defining the parts of a polynomial equation. So let us now proceed to finding the roots of a polynomial equation. Now there are three parts or three ways in finding the roots of a polynomial equation. One of which is its degree, The second one is the possible root, and the third one is by trial and error using synthetic division. Now, I would like to emphasize that in trial and error, we can always use a lot of varieties to show or to find its roots. Okay, so for this time, I will be using synthetic division because it is a lot easier for us to find the root of a polynomial equation using synthetic division. Now, the question is, are there polynomial equations that has no roots? Yes, there are polynomial equations that has no roots. One of the reasons that the polynomial equation has no roots is because it might be that the roots are in imaginary form, or you can say that the polynomial equation has no roots if and only if you exhausted all the possible ways, or you have tried all the possible roots and there are no roots. Okay, let us try this example. Number 1, x cubed plus 5x squared minus 4x minus 20. So for this equation, we can see that the degree is 3. So we can always expect that the degree is equal to the number of roots. In order for us to get the possible roots of a polynomial equation, we must first define the p over q. So what is the p over q? P is or are the factors of the constant, and the q are the factors of our leading coefficient. So all in all, the possible roots will become the p over q. So first, we will know or we will define what is the constant and the leading coefficient of a polynomial equation. For this equation, x cubed plus 5x squared minus 4x minus 20, the leading coefficient is 1. So you can see that the leading coefficient is 1. So for this time, since our leading coefficient is 1, we will proceed now directly to our next step. And also, the constant is equal to negative 20. So for our constant, we will only be thinking of the factors of our constant. Now, this is now the brilliance of the possible roots. We can only find the factors, or we will only find the factors of the constant. Para mas dali sa ato, dili kayo magpataka na lang ang pangita og factors, we will be narrowing down the factors or the possible factors of this polynomial equation by starting with the factors of our constant, which is negative 20. So what are now the factors of negative 20? So the factors are positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, and positive negative 20. So since, again, our q, or the factors of our leading coefficient is 1 lang siya, so we will now proceed. So we already have our degree, we already have our possible roots. Next thing to do is by trial and error. And in this trial and error, we will be using synthetic division because for me, it is a lot easier. You can always use the factor theorem, the rational root theorem, by substituting the value of your roots to the equation. And if it will satisfy or the answer is 0, then you can say that the value is a factor of that certain polynomial. By using negative 2, we can see that the remainder is 0. Therefore, negative 2 is a factor. And I have tried the value of 2. As you can see, the remainder is 0. So therefore, 2 is a factor. And you can see that the answer is x plus 5. And by factor theorem, x plus 5, the answer is negative 5. So the roots now are negative 2, positive 2, and negative 5. Now for our second example, we will be using this equation. 2x cubed plus x squared minus 5x plus 2 is equal to 0. Now, by step 1, we will know the degree of this polynomial. Now we can see that the degree is 3. So we can say that we can also expect that this polynomial has 3 real roots. Our leading coefficient is equal to 2. So our p now, or the factors of 2, are positive negative 1 and positive negative 2. So for our leading coefficient, which is also 2, our q now is also positive negative 1 and positive negative 2. So we will now be dividing the values of p to the values of q, so that we can now get the possible values or the possible roots of our polynomial equation. So here we can get the values of p over q, which are positive negative 1, positive negative 1/2, and positive negative 2. And from those possible roots, we can find our roots. So by trial and error, we can see that I have tried the possible value 1, and it turned out that the remainder is 0. So we can say that 1 is one of the possible roots. I have tried positive 1/2, and it turned out that the remainder is 0. So therefore, 1/2 is one of the roots. And the answer is 2x plus 4 is equal to 0. And by factor theorem, 2x plus 4 will become x is equal to negative 4 divided by 2, and it will become x is equal to negative 2. So therefore, the roots of the polynomial equation 2x cubed plus x squared minus 5x plus 2 is equal to 0 are 1, 1/2, and negative 2. So students, thank you for listening, and I hope that you have learned something from this video. Thank you and God bless.